Hello guys. In today's video, I'm going to explain something about operators in quantum mechanics. Now, first of all, what is operator? First of all, operator is a rule. Operator is a rule or operator. An operator is a rule, okay, or something which can convert or interchange a function, one function to another function. Operator is a rule which can change a function to another function, right? For example, if I say 2 plus 3 in simple mathematics, 2 plus 5 is equal to what? 2 plus 5 is 7, right? So in this case, this is an operator in simple mathematics. In mathematics, plus is an operator. Just like plus, there are minus is there, into is there, okay, multiplication is there, division is there. They are all operators. So like plus, minus, right, into, division, which are operators in mathematics. Similarly, we have operators in quantum mechanics also. So in quantum mechanics, like I said, operator is a rule which can convert one function to another, which means an operator has no meaning. An operator has no meaning without a function. Means if there is no function, then what is the need of operator? There is no need for any operator, right? Operator has meaning only when there is a function. So let me give some operators in quantum mechanics. For that, let me rough this page. Okay, first operator in quantum mechanics is some operators, right? Some operators in quantum mechanics. The first operator is position operator. Position operator is represented by this x cap. So in operator, cap is cap is put above the symbol. So position operator is nothing but x cap. This is its function is, the function is multiplication, just multiplication, right? Multiplication by x, that is the operator. Multiplication by x. Operator position x means multiplication by x, right? So means if x is an operator, then we can say the function in quantum mechanics is represented by psi. That is, for example, wave function in quantum mechanics is represented by this psi. And if x is the position operator, then psi we represent like this: psi x cap psi, like this. So this is just multiplication by x, that is position operator. Next important operator in quantum mechanics is momentum, right? Momentum operator is represented by p. px, let me give in one dimension, momentum operator. So momentum operator px is represented by minus I h cross d by dx. So this h cross is reduced Planck's constant. Its value is equal to h upon 2 pi. This is reduced Planck's constant, and if this is momentum operator in x dimension, then total momentum is also there. But before that, let me tell what is this I is iota. I is pronounced as iota. Iota is just an imaginary number. This is an imaginary number, right? This is an imaginary number. Okay, iota is an imaginary number, and I square is equal to minus 1, which means I is equal to under root of minus 1. This is about I, which is pronounced as iota, right? Okay, so next operator is, let me clear this page. Next operator in quantum mechanics is total momentum. Total momentum is represented by p cap, right? This is p cap. So this is nothing but p cap is the sum of px cap, py cap, and pz cap, which must be equal to minus iota h cross d by dx, right? Plus there will be minus here, minus I h cross d by dy in case of y, and minus I h cross iota d by dx, oh sorry, dz. Okay, so this can be written like this: minus iota h cross d by dx plus d by dy plus d by dz. So this is our total momentum operator in quantum mechanics. Okay, next very important operator in quantum mechanics is, okay, the fourth one is kinetic energy. Kinetic energy operator. Kinetic energy operator is represented by, let me represent it as kx. This is kinetic energy. Okay, kinetic energy is equal to half mv square, which can be written as half m square v square divided by m. 1m and 1m cancel out to get this mv square. So this can be written as mass into velocity is momentum. This is p, so p square by 2m. This is kinetic energy. Kinetic energy is p square by 2m. So therefore kinetic energy operator will be equal to px, let me write for one dimension only, for x direction, px square cap, right? Px square cap divided by 2m, which will be equal to, px is what? Px is minus iota h cross d by dx minus iota h cross d by dx is px squared divided by 2m. This can be written as minus 1 square is 1, I square is minus 1, like I have already told. I square will be minus 1, that this is minus h cross square. This is kinetic energy operator, right? Minus h cap square d square by dx square divided by what? 2 m, right? This is our kinetic energy operator in quantum mechanics. This is in one direction only. So total kinetic energy will be equal to sum of kx, ky and the kz, right? So let me write, let me rough this page first. The next operator, the fifth one, will be total kinetic energy. Let me write kinetic energy Ke. This will be represented by K cap. So this will be K cap, which must be the sum of Kx cap and the Ky cap and the Kz cap, that will be equal to minus h cross square divided by 2m for this d square by dx square, right? And this will be for ky also. Ky will be equal to minus h cross square divided by 2m d square by dy square. So let me take the common of this minus h cross square by 2m, and this will give our d square by dy square plus d square by dz square. This can be delta also, but I'm writing d by dx dy dz here. Okay, this is the total kinetic energy operator in quantum mechanics, right? K cap. This is the value of K cap in quantum mechanics, right? This is d square by dz square. Okay, let me give you one more operator in quantum mechanics, that is Hamiltonian operator. Hamiltonian operator, right? Hamiltonian operator is represented by h cap, capital H cap. This is Hamiltonian operator. This operator is the operator of total energy actually. This is the operator of total energy. Total energy means kinetic energy and potential energy, right? So potential energy is represented by V in quantum mechanics, and the kinetic energy will be represented by K. So Hamiltonian, therefore Hamiltonian operator will be equal to this is T, also Kx. Let me write for one dimension only, Kx cap plus what? Vx cap, right? So Vx will be same. Kx is equal to minus h cross square divided by 2m d square by dx square plus Vx. This is the Hamiltonian operator in one dimension. So in three dimension, Hamiltonian operator will be represented by, this is in what, hx cap. This is hx cap only, in the x direction only. In three dimension, this is in one dimension, right? This is in one dimension, and in three dimension, let me write in the another slide. Let me rough this page for writing. Okay, in three dimension, Hamiltonian operator is, let me write this by h cap, which will be sum of hx cap and hy cap and hz cap, and hx will be equal to minus h cross square by 2m d square by d x square plus vx. This will be the value of hx cap, and plus minus h cross square by 2m d square by dy square plus vy cap, right? This is cap. This is for hy, and the plus minus h cross square divided by 2m d square by d z square plus v z cap. So if we here actually hx is equal to what? This is kinetic energy plus potential energy in x direction, and this is in 3 dimension. This is the representation of total kinetic energy operator, which means Hamiltonian operator in 3 dimension. Okay, this is all about in today's video. In the next video of quantum mechanics, I will come up with angular momentum operator. Please share this video if you like, and please subscribe to the channel, and also press the notification button. Thank you for today.